This unit has a hydrogen feature to it, which we will not be demonstrating today. The hydrogen is a handheld manual operation, but for our automatic feature is the pressure decay, and that's what we will be showing you. I'm going to close the guard door so I can go through some of the presets setup of the machine. This is the system directory screen. No, it's not. Let me go back. This is the system directory screen. This presents you with automatic mode, your pressure presets or your unit presets, and also allows you a manual operation as well. And it will display current presets for the unit selected and the test results of the previous test. To give you some idea of how to program, we'll go into the preset screen. Here we have a password screen that requires a password. This is to help this is to prevent the operator from actually changing the presets of the screen. This should only be done by a supervisor or key person. Password for this model is 2535. And in this directory, we have unit presets and system presets. The unit presets are all the presets unique to the size unit you're testing. They will vary from unit to unit as far as pressure and time period. The system presets are presets that are common to all the tests, regardless of the size of the units. To be quick, we'll go into the system presets. The presets that are of interest today are the high pressure step pressure and this high pressure step time. This is a watchdog logic feature that monitors the pressurization of the coils. If they fall outside of a 2-pound change in 10 seconds, if that is not achieved, a screen will come up and alert the operator that there's a problem with the supply system and to check various components of that supply system. The other preset of interest today is the consecutive PLT faults. Right now we have a preset of 3. What that preset is used for is if there are 3 consecutive failures of the pressure decay leak test, it usually indicates that there may be a problem with the system or the production of the units has a flaw. It's just there to make the operator aware that there may be a potential problem with the system. The others pertain to again to the hydrogen portion that we're not demonstrating today. Okay, let me go back, show you the presets that we had programmed for this unit, for this flat plate heat exchanger. The first preset, upper left-hand corner, is the charge pressure. It's what the unit will be filled to. Right now that preset is at 400 pounds. Next to it we have the high pressure offset, and what that variable is for is to allow the unit to be charged to the 400 pounds plus 20 pounds. And what happens during any charge period or charging of any vessel, as soon as the supply valve is closed, there will be a pressure drop. The 20 pounds is to offset that pressure drop at the end of the filling process. Settle time is the amount of time that we allow for the temperature and pressure within the unit to stabilize. There are physical limits in pressure decay, one of them being heat of compression, and also the temperature of the air entering the coil will create an offset. Because it's a pressure decay system in a fixed size vessel, temperature has a has a great impact on the accuracy and the ability to find a leak with pressure decay. So you want to make sure that the temperature and pressure of the system has stabilized, of your unit has stabilized before you begin the test. Right now that stabilization time is for 60 seconds. The PLT time itself is the amount of time that we witness the pressure decay. At that point, we take a snapshot of the pressure. So we have a fixed number of what the pressure is, and then we measure against that fixed pressure over time and see what the delta pressure is. That delta pressure represents the pressure drop after stabilization time. It goes more than, if the pressure drop exceeds a half a pound, the unit is deemed as to fail. These presets were predetermined manually using pressure and time, and these were found to be stable readings for those units in the manual profiling test. We have a compare feature on this machine that will actually compare the two rates of change in both circuits at the same time. However, I'm not sure of the volume in each one of these two circuits. I'm not sure if they're identical, therefore I'm not going to use the compare. If they were, if the two circuits are identical, you can use the compare feature. It adds another degree of reliability in the pressure decay system that allows you to compare the two rates of change in both sides compared to each other. If one leaks more than the other, it could be determined that that unit does have a leak, even though the pressure drops are continuing. Presets on the right-hand side of the screen are more for the hydrogen system, and we're not going to demonstrate today. Each unit, this particular unit I should say, is equipped with a barcode scanner where you could scan a barcode at this time and associate that with unit number 1. At the end of your presets, I'll just show you how a preset is made. Right now, I'm going to enter in 400 pounds to give you some idea how easy it is to enter your presets. And then you would hit your store button. Now all these presets are stored. There are 1 in 48 unit storage numbers that you can use, recipes. Return. System presets I've already explained. And now we're going to go to our automatic mode. Again, we're just going to show you the pressure decay leak test. At the end of the pressure decay leak test, I will shut the machine off because it wants to do its hydrogen test after that. We would give you a machine or just does pressure decay. So I'll begin the test. We hit reset first and then start. You control the amount of flow into the coils with a needle valve, a flow valve. You can see the pressure drop, immediate pressure drop. And now the unit's we're letting the unit stabilize pressure and temperature for 1 minute. And that is displayed on the elapsed timer. We're now at 20 seconds. Flat plate heat exchangers, because of their mass, require a longer settling time to make sure that the temperature is a constant.